This video is all about solving complex equations by making a substitution. But first, a quick reminder that we know how to solve quadratic equations such as 2x squared minus x minus 3 equals 0. We can either do that by factorising, like I've done so in blue there, or we could use the quadratic formula, like I've done in green. You can see we get the same answers either way. And it's always a good idea to check your answers to see if you've definitely got them correct. So what I mean by checking is take one of the x values. So for example, if I want to check to see if 3 over 2 is correct, I can substitute 3 over 2 into this equation here and here. And as long as all of this equals 0, I know 3 over 2 is a valid solution to the equation. So, just to recap, we know how to solve equations that are in that form, in the quadratic form, ax squared plus bx plus c equals 0, where the term at the front here is this term squared, and we have a constant term on the end. Now, we should be on the lookout for similar situations to that. For example, if I've got x to the power 4 minus 7x squared plus 12x equals 0, that is a similar situation because I've got the constant term on the end, and notice that this term is this term squared. In the second example, again we've got a constant term on the end, and notice that this term is this term squared. And then in the third example there, we've got a constant term on the end, and again notice that this term is this term squared. Might not be as obvious, that last one, so let me just show that one to you. If I've got 2 to the power x squared, that's 2 to the power x times 2 to the power x, which is 2 to the power 2x, because we're adding the powers, and that is that term there. So we should be on the lookout for situations like these because we can actually turn all of these equations here into quadratics to solve them. And we're going to do that by making a substitution. So let's go through, I'm actually going to do 4 different examples here. So example 1, I notice that this term is this term squared. So I know I can solve this by making a substitution. So I'm going to say I'm going to substitute the x squared for a different value. I'm going to call it t for now. You can call it whatever you want, it doesn't matter. I'm going to say that t is x squared. And then I know that if I square t, I would have x squared squared, which is x to the power 4, which I'm going to substitute in here. So my equation is going to become the x to the power 4 becomes t squared. I've then got minus 7 lots of the t because the x squared became t. The plus 12 is still there, and that equals to 0. So just to repeat what I've done, I noticed that this was this squared. Therefore, I decided I was going to choose a letter to replace the x squared with. I chose t. So you can see that I've taken this x squared here and I've replaced it with t here. Then notice that t squared is going to replace the x to the power 4. So I've replaced this x to the power 4 here with the t squared here. Now, I've got this quadratic equation which I can solve by either factorising or using the quadratic formula. This is pretty easy to factorise though, so I'm going to do that. I'm going to have t minus 4 and t minus 3. Which gives me two solutions. It gives me that either t is 4 or that t is 3. But I need to remember that t was this letter, this variable that I've just made up at this stage here. I chose to use t. It has no relation to the question itself. I want to know what x is. So now I'm thinking, well, what was t in the first place? It was x squared. So I've got that x squared is actually equal to 4, or that x squared is actually equal to 3. I'm now going to square root. So square rooting the 4, I'm going to get either positive 2 or negative 2, because 2 squared is 4, and also minus 2 squared is 4. Square rooting the 3, I'll get plus minus root 3. And I think those are the 4 different solutions to this quartic equation. And just like I said before, we can check all of those. So if I substitute 2 in here, 2 to the power 4 minus 7 lots of 2 squared. So 2 to the power 4 is 16. 2 squared is 4 times the 7 is 28. Plus the 12. And as we can see, that does equal 0. So 2 is a valid solution to this equation. And I should also check minus 2, plus root 3, and minus root 3. And in this situation, all 4 of those solutions work. Second example. X equals 3 root x plus 4. So I notice I've got a constant term here. And most importantly, I notice that if I were to square this, I would get this. So this is a situation where I can use a substitution to turn this into a quadratic. So I'm going to say let t, I'm going to use the letter t again, to be my root x. That way my t squared would be just x. So this x here gets replaced with t squared, and that's equal to the 3 lots of root x, that's 3 lots of the t, plus the 4. Now, in order to solve this quadratic equation, I want it to equal 0, so let me subtract the 3t from both sides and subtract the 4 from both sides. And now I'm going to factorise that to solve. And we're going to have a minus 4 and a plus 1. So t is either 4 or t is equal to minus 1. But remember, I don't want to work out t, I want to work out x. So I then need to think, well, what was t? It was root x. So actually, I'm saying that root x is equal to 4, or root x is equal to minus 1. So to actually work out what x is, I'm going to square both sides. So square the 4, I get 16. And I'm going to square the negative 1. Minus 1 squared will be plus 1. And let's do a quick check. Let's see, do these answers work? So let's check the 16 first. So 16, does that equal 3 lots of the square root of 16 plus 4? Well, the square root of 16 here, that's 4. So times the 3 will be 12. Plus the 4 is 16. So yes, that one works. Let's check the 1. Does 1 work? Does 1 equal to 3 lots of the square root of 1 plus 4? Well, the square root of 1 is 1 times the 3 is 4. Times 3 is 3. Plus the 4 is 7. It is not equal to 1. This is not actually a valid solution to the equation. So I'm not going to give x is 1 as a solution. 16 is the only valid solution to this equation. So that check was important. So do the check for these questions. Do substitute the values back in at the end and make sure they work. Third example. Again, I notice that if I were to square 2 to the power x, I do get 2 to the power 2x, like I explained earlier in the video. So I'm going to say let t be 2 to the power x so that t squared becomes 2 to the power 2x. So this is my t squared. I've then got minus 12 lots of the t plus 32 is equal to 0. Factorise. And I find that either t is 8 or t is 4. But we know that I don't want to work out t, I want to actually work out what x is. So remember, what is t the same as? It's 2 to the power x. So 2 to the power x is equal to 8, or 2 to the power of x is equal to 4. Well, let's just think 2 to the power of something is 8. It's 3. 2 to the power 3 is 8. 2 cubed is 8. And if I 2 to the power x is 4, that's got to be 2, because 2 to the power 2, 2 squared is 4. And those are the two solutions to that equation. Again, do a quick check to make sure you've got it correct. Substitute 3 in here. 2 to the power of 2 times 3 minus 12 lots of 2 cubed plus 32. Make sure you get 0. And do the same thing with the 2 as well. Make sure both of these are valid solutions. And final example, the fourth example for here. And you can see I've already shown all my working out. The main thing I want to talk about here is when you first look at this equation, it might not be clear that this is of the same form as the other ones, which is why I didn't put it on that first slide. It might look completely different to begin with. But actually, if we're careful with our index laws, we can see that it does turn into a quadratic. So let me talk you through that. I know that the 4 can be written as 2 squared, which then becomes, when I put that to a power x, that then becomes 2 to the power 2x. I've got this plus 2 here as well. It's a bit unusual. Well, I know that if I've got 2 to the power of x plus 2, if the powers are being added, I can split that power up as long as I multiply the bases. I know that 2 to the power x times 2 to the power 2 is the same thing as 2 to the power of x plus 2. And writing it like that's useful because 2 squared is just 4. So I've actually just got 4 lots of 2 to the power x. which I could actually just swap those round and put the 4 at the front. So once you've spotted all of that, you can see that I've actually managed to turn that equation into this equation. And now that does look like a quadratic where this term squared is this term. So that's why I've said that t is 2 to the power x, t squared is 2 to the power 2x, and then I've followed that through just like I've done in the previous examples. The only extra thing I should probably point out here is one of those solutions I ended up saying that 2 to the power x is negative 4, which is not possible. You can't do 2 to the power of a number and get a negative answer. So I'm not going to include that as part of my answer. The only answer to this equation is 3. And like I say, do double check that. Substitute 3 back. 4 cubed minus 2 to the power of 5. Yes, that does equal 32, so that is a valid solution. So that's it. That's how we can solve complex equations by making a substitution. You want to be on the lookout for situations where this is this squared, this is this squared, this is this squared. If you can spot that, then you can say, well, t is this, therefore t squared is this. T is this, therefore t squared is this. T is this, therefore t squared is this. Then you can solve the quadratic and swap back at the end, double checking your answers.